Welcome to Samveda E-class, 7th standard subject mathematics, chapter 1, integers, session 2. Students, in first session some problems are given to solve. I think you are all solved it. Before second session, homework problem is a water tank has steps inside it. A monkey is sitting on the topmost step, that is the first step. The water level is at 9th step. He jumps, first one is 3 steps up and then jumps back 2 steps up, okay? 3 steps down, 2 steps up. In how many jumps will he reach the water level? Monkey reach water level in how many jumps? Okay. Next question, after drinking water he wants to go back. For this he jumps 4 steps up and then jumps back 2 steps down in every move. In how many jumps will he reach back the top step? Okay. Third question, if the number of steps moved down is represented by negative integers and the numbers steps moved up by positive integers represented, is moves in part 1 and part 2 the completing the following: a minus 3 plus 2 minus etc. is equal to minus 8, b 4 minus 2 plus etc. that is equal to plus 8. In A, the sum minus 8 represents the monkey going down by 8 steps. So, what will be the plus 8 in B represents? This is the question I given for homework. We go for solution. First one, what is the point? He jumps 3 steps down and then jumps back 2 steps up. In how many steps will he reach the water level? See one activity, the how monkey jumps to first steps to 9th steps. Monkey is in first step, he jumps to 3 steps down, that means first jump, and he reaches 4th step. Next he jumps back 2 step, that is second jump, that is second step. Again he down jumps 3 steps, that means 5th step, and jumps back 2 step back 3. Next 5th jump 6th and 6th jump 4th. Next 7th jump, yes 7th jump. Next 8th jump, that is in 5th. Next 9th jump is in at 8th. Next 10th jump is at 6th step. When it jumps to 3 step down, it jumps to 9th step, reaches the 9th step and drink the water. Okay. This is the how to monkey jumps by first steps to 9th step. See here the table is given here, jumps and down and up position. First jump down or up, down 3 steps, that is 4th step. Second up 2 steps, second step. 3 down 3 steps, 5th step. 4th, that is up 2 step, 3rd step. 5th down 3 step, that is 6th step. 6th jump 2 steps up, that is 4th step. Next 7th jump down 3 steps, 7th step. In jump 8 you 2 steps up, that is in 5th step position. Next 9th step down 3 steps, 8th step is in 8th step. On 10th jump he jumps back or up, he 2 steps ups, that is 6th step position. On 11th jump he downs 3 steps, position on 9th step. The water level is at 9th step. That is why the monkey jumps 11 times to reach a water level. Very good. You understand it? Next, second question is, what is the second question? After drinking water, he wants to go back. For this, he jumps 4 steps up and then jumps back 2 steps down. In every move, in how many jumps will he reach back the top step? We go to solve. What is the position? The monkey's position at 9th step. He want to go back at first step. What is the condition? First ups 4 step jumps. That is first jump. Where is its position? 5th step. Next down, how many steps? 2 steps. That is second jump at 7. Again he jumps up 4 steps. That is on third jump he reaches the third step. Next he jumps down 2 steps. That is 5th step. Again he jumps up. Then he reaches the first step. The monkey reaches back. That is how many jumps he takes to go back? That is 5 times he jumps to reach first step. See the table here. First jump, second jump, third jump, fourth jump, fifth jump. In first jump, up 4 step. In second jump, 2 down. Third jump, up 4. Fourth one, down 2. Fifth one, up 4. See here position. Fifth, seventh, third, fifth, 1. That is 1. That means the water level is at 9th step. Then the monkey jumps 5 times to reach first step. What is the third question? If the number of steps moved down in represented by a negative integer and the number of steps moved up by positive integers, the represented is moves in part 1 and 2 completing the followings. That is -2, -3, +2, minus etc. is equal to -8. B 4 -2 plus etc. is equal to +8. In A, the sum -8 represent going down by 8 steps. So, what will be the sum 8? In B, represent A -3 plus 2 dash dash is equal to -8. Total jumps 11 jumps. The down means negative, up means positive. Down 3 steps means -3, up 2 steps means similarly B. Same, up means positive, down means negative, that is +4 -2 +4 -2 +4. Same as in A, -3 +2 -3 +2 -3 +2. How many times? 11 times. Here 11 times, here 5 times. -3 +2 -3. What is the sum? That is -8. The -8 in A, the sum -8 represents the monkey going down by 8 steps. In B, 4 -2 4 -2 4, that is 8. In B, the sum 8 represents monkey going up by 8 steps. I think understand you well. Good. We go for second session. In second session, we discuss about the properties of addition and subtraction of integers in second session. The first one is closure property, commutative property, associative property and additive identity. Last one, additive inverse. These are the properties of addition and subtraction of integers. We go through one by one. We discuss first one, that is closure property. The closure property under addition. In previous class, that the sum of two whole numbers is again a whole number. One example, 12 plus 21 is 33. Okay, 12 plus 21 is 33. Which is again a whole number? Yes, 33 also a whole number. Any two whole numbers is again a whole number. This is the closure property. Let us see whether this property true for integers or not. Can we verify it? Okay, go through. First observe the following statements, then after we discuss. Statement 1, 17 plus 23 minus 10 plus 3 minus 75 plus 18, 19 plus minus 25, 27 plus minus 27. First one, what is the answer? That is 40. 40 is an integer? Yes, 40 is an integer. Very good. Next one, what is the answer? Minus 7. Minus 7 is also an integer? Yes, very good. Third one, minus 57. minus 57 is also a integer? Yes, integer. The fourth one, minus 6, yes, an integer. Fifth one, 0, 0 is an integer? Yes, 0 is an integer, very good. What do you observe here? Did you find a pair of integers whose sum is not an integer? No, all are integers. What happens when add an integer from another integer? We get a here also. Third question, we can say that their sum is also an integer? Yes, their sum is also a integer. Fourth one, can we say integers are closed under addition? Yes, integers are closed under addition. The addition of integers gives an integer. This is the statement. Okay. We say integers are closed under addition in general for any two integers a and b is a plus b is an integer. That means a plus b is equal to c. C is always an integer. Next, closure under subtraction. Closure under subtraction, we already learned that the difference of two whole numbers is not a whole number. Why? Take one example, 12 and 21 are two are whole numbers? Yes, 12 and 21 are whole numbers, but when we subtract these two, the difference of these two is minus 9. Minus 9 is a whole number? No, minus not in whole number. That is why minus 9 is not belongs to whole number. That is why this property not holds good. This is not a whole number. Let us see whether this property is true, integers or not. It holds good or not in integers. Okay, verify it. Observe the following statements. First, what is the statements? First one, 7 minus 9. Second one, 17 minus of minus 21 and minus 8 minus of minus 14. Fourth one, minus 21 minus of minus 10. 32 minus minus 17. Next, what is the answer? First one, minus 2. Very good. Minus 2 is an integer? Yes, is an integer. Second one, what is the answer? 38. 17 minus into minus plus, that is 20 plus 21. 17 plus 21 is 38. 38 is also an integer? Yes. Minus 8 plus 14, that is 6. 6 is an integer? Yes, as an integer. Minus 21, that is minus of minus 10 means plus, that is minus 21 plus 10 is minus 11. Minus 11 is in an integer? Yes, very good, is also an integer. 32 minus of minus 17 is 32 plus 17 is 49. Very good, is an integer. We observe this. What do you observe here? Next, what happens when subtract an integer from another integer? We get integer. Second, can we observe? Can we say that their difference is also an integer? Yes, their difference is also a integer. Next, if there any pair of integers whose difference is not an integer? No, all are integers. Next, what is the observation of last one observation? Can we say integers are closed under subtraction? Yes, integers are closed under subtraction. Subtraction of integers gives an integer. We say integers are closed under subtraction. Generally, if a and b are two integers, then a minus b is also an integer. That means a minus b is equal to c. C is always an integer. We go to next property. What is the next property? Second one, that is commutative property, addition. Already we know that 3 plus 5 is equal to 5 plus 3 is equal to 8. 5 is a whole number? Yes. 3 is a whole number? Yes. 3 plus 5 and their reverse is 5 plus 3. Their sum is always equal. The whole numbers can be added in any order. The sum always same. That is why the addition is commutative for whole numbers. Let us see whether this property is for integers or not. Observe the following some questions. Then after we discuss it. There are three questions is here, minus 8 and minus 8 plus minus 9 and minus 9 plus minus 8, the reverse order. minus 23 plus 32 plus 32 plus minus 23 minus 45 plus 0, 0 plus minus 45. What happens? See here, minus 8 plus minus 9 is minus 17, same minus 9 plus minus 8 minus 17, minus 23 plus 32 is plus 9, 32 plus minus 23 is also plus 9, minus 45 plus 0, also 0 plus minus 45 minus 45. What you observe here? What happens when two integers are added irrespective their order? Their sum is always equal. Next, what we observe? Can we say that their sum also remains the same on both sides? Yes. And finally, we say that the addition is commutative for integers. In general, for any two integers a and b, we can say a plus b is equal to b plus a. Next, subtraction, commutative property, subtraction. What is the subtraction? We already know that 3 and 5 are whole numbers. Their subtraction, 3 minus 5 and 5 minus 3 are all equal. See here, 3 minus 5 is minus 2, 5 minus 3 is plus 2. They are equal, they are not equal. Then we know that the subtraction is not commutative for whole numbers. Is it commutative for integers? Can we verify it? First, to observe some examples. 3 examples are given here. Minus 8 minus minus 9. Reverse, minus 9 minus minus 8. Second one, minus 23 minus 32. 32 minus of minus 23, minus 45 minus 0, and 0 minus of minus 45. Here first one, both are equal? No, here is plus 1, another side is minus 1. Next, one side minus 55 answer, another side plus 55 is the answer. Third one side minus 45 answer, another side plus 45 is answer. Then what we observe here? What happens when two integers are subtracted irrespective of their order? They are equal? No, they are not equal. We can say that their sum also remains the same on both sides, but same but opposite sign. That is why they are not equal. We conclude that the subtraction is not commutative for integers. In general, for any two integers a and b, we can say a minus b is not equal to b minus a. Next, associative property. Look at, we will check given example whether we get different results or no. First one, minus 5 is a number. We take another number, that is minus 3 plus minus 2, that is minus 5 is one number. The two numbers are taken together, that is minus 3 plus minus 2. First we add minus 3 minus 2, that is why. What is the result? Minus 5 as it is plus minus 3 minus 2 means that is minus 5. That means minus 5 plus minus 5 is minus 10. Next, minus 5 plus minus 3 is taken together. Next, plus minus 2. That means the first two add first, then minus 2 next. That is why minus 5 plus minus 3 is how much? Minus 8. Very good. Next, plus minus 2. What is the minus 8 plus minus 2? That is minus 10. Answer is equal? Yes, very good. Minus 10, minus 10 both are equal. What we observe here? Can we say that their sum also remains the same on both sides? Yes. We conclude that the addition is associative for integers. In general, for any integer a, b and c, we can say a plus b bracket b plus c is equal to bracket a plus b plus c. Next property, that is additive identity. The additive identity means when we add 0 to any whole number, we get the same whole number. That means 8 plus 0 is 8, 0 plus 8 is 8. The 0 is an additive identity for whole numbers. Same for integers, it is an additive identity again for integers also. Can we check? 23 plus 0 is equal to minus 23. Second one, 0 plus minus 37 is equal to minus 37. Third one, 0 plus minus 59 is also a minus 59. Fourth one, 0 plus what we add here to get minus 43? Yes, we add minus 43 to get minus 43. 0 plus minus 43 we get minus 43. The answer is minus 43. Minus 61 plus what we add here to get minus 61, that is 0. Very good. Minus 61 plus 0 is equal to minus 61. Here the above examples shows that 0 is an additive identity for integers. All examples are shows that 0 is an additive identity for integers. In general, for any two integers a plus 0 or 0 plus a plus 0 or 0 plus a, both are equal to a. Next, additive inverse. The last one property, additive inverse. What is the additive inverse? The additive inverse is a number which on getting added to the original number results in 0. The additive inverse is a number which on getting added to the original number the result in 0. Is it additive inverse for integers? We will check. Observe the followings. There are 5 examples are given here. 23 plus minus 23. 23 is a number, minus 23 is a the inverse of 23. Therefore, 23 plus minus 23 is equal to 0. Second one, 37 is a number. The inverse of 37 is additive inverse of 37 is minus 37. Then what is the sum of these two? Is also a 0. Next, third one, minus 57 additive inverse is plus 57. Once again, minus 57's additive inverse is plus 57. The sum of these two is also 0. Next, fourth question, minus 43 is given plus what we add to get 0. What is the inverse of minus 43? The minus 43's inverse is plus 43. Then what is the answer? Plus 43. Then minus 43 plus 43 is equal to 0. Next, fifth one, the plus 61 is the number. What is the inverse? The inverse of 61 is minus 61. Very good. Then minus 61 plus 61 is equal to 0. Okay. Next, the above examples shows that a integer is added to their inverse else 0. Therefore, every integer has their inverse. In general, the additive inverse of a is minus a. Additive inverse of a is minus a, and we can say a plus minus a is equal to 0. Next, students, in this second session discuss about the properties of integers, addition and subtraction integers. Dear students, next we go to solve exercise problems. First one problem, what they given? Write down a pair of integers whose sum is minus 7. Solution. This is the integers number line. These are integers. We take two integers. First one minus 4 and minus 3. Add these two. Minus 4 plus minus 3 is again minus 7. Very good. Is minus 7. Write a pair of negative integers whose difference gives plus 8. These are integers. We take two negative integers which are minus 1 and minus 9. Minus 1 is also negative integer, minus 9 is also a negative integer. We take two negative integers, their difference means subtraction. Minus 1 minus of minus 9 is minus 1 plus 9, that is equal to plus 8. Very good. Third question, write a negative integer and a positive integer whose sum is minus 5. Read carefully. My negative integer, one negative integer, one positive integer, their addition, their sum is minus 5. Their sum is minus 5. Then what is the solution? This is integer, we know. Next, which numbers we take? Minus 9 and plus 4. Minus 9 is a negative number? Yes. Plus 4 is a positive number? Yes. Therefore, minus 9 and plus 4 are negative and positive integers. What we do here? Add, sum. Then minus 9 plus 4. Minus 9 plus 4 is minus 5. We get minus 5? Very good. Next, write down a pair of integers whose sum is 0. Solution same, we know, integers number line. Then which numbers we take? Yes, number and their inverse. A integer and their inverse, their sum is always 0. We know that, that is additive inverse. Similarly, 7 and minus 7 are integers. Then sum of these two, 7 plus minus 7 is equal to 0. Yes, we get it. Minus 7 is a inverse of plus 7. Thank you, dear students. We discuss in second session about properties of addition and subtraction of a integers. Next, some problems are given for homework. You do it and check it your teachers or your parents. First question, fill in the blanks to make the following statements true. If given statements are true, then fill in the blanks. First question, minus 5 plus minus 8 is equal to minus 8 plus dash. Okay. Second question, minus 53 plus dash is equal to minus 53. Third question, 17 plus dash is equal to 0. Fourth one, 13 plus minus 12 plus dash is equal to 13 plus big bracket minus 12 plus minus 7. Fifth one, minus 4 plus big bracket 15 plus minus 3 is equal to big bracket minus 4 plus 15 plus dash. Next one, in a quiz competition, team A scored minus 40, 10, 0 and team B scored 10, 0, minus 40. In 3 successive rounds, which team score more? Can we say that we can add integers in any order? Solve these two questions in your notebook and show your teachers or parents. Correct it. Thank you, students.